Okay, today we are going to discuss about solving linear programming problem by using graphical method. So what is a linear programming problem? Linear programming is an optimization method to maximize or minimize an objective function in a given mathematical model with a set of requirements represents as a linear relationship. So simply known as a linear programming is a mathematical model which is used to generate a mathematical model for the any kind of real life problem by using the linear programming. General linear programming model. So now we are going to discuss about the general model of the linear programming. Okay, so this model contains three components. One is for objective function, and second one is a constraint, and third one is the non-negative constraints. So in that objective function, we want to define based on our problem nature. We can consider maximize or minimize. Suppose if the problem is depends on the profit, then we can consider as maximize. Suppose the problem is based on the production, we want to reduce the production cost, then we can consider as a minimize. So now we can define the objective function z is equal to p1 x1 plus p2 x2 etc plus pn xn. Here x1 x2 etc xn are all that products, and p1 and p2 pn are known as the unit cost for the respective product. So now we can define a constraint. So w11 x1 plus w12 x2 plus etc w1 n xn less than or equal to or greater than or equal to w1. So here w1 is known as the availability of the resource. So either depends upon the availability, we can use the notation for less than or equal or greater than or equal to. Suppose if we have only for 100 rupees, we can use up to 100 rupees only. We can't use more than 100 rupees. So during that time we can use for less than or equal to. Suppose the product is equal to the particular amount, then we can spend that particular amount only. So during that time we can use for equality. Suppose if you want to need at least that much amount for a particular event, if we want to do some particular event, we need at least this much amount. Okay, for suppose if we want to go for one place to another place, we can use for any kind of mode of transportation, but at least we need for certain amount if we want to move from that place to another place. So during that time we can use for greater than or equal to symbol. So likewise we can define for various constraint based on the given problem. So here we can consider up to m constraints we have. So in the last constraint is wm1 x1 plus wm2 x2 plus etc wm1 xn less than or equal or greater than or equal to w. So it depends upon the nature of the availability, we can use these three symbols. Then we can consider as non-negative constraint xi greater than or equal to 0. Either we can consider the quantity as whole product or the product is not available. We do not consider for the negative values. That means the defective products. We do not consider the defective products. So that here we can use for xi is greater than or equal to 0. So what is a graphical method? The graphical method represents optimization algorithm for solving linear programming problems containing two decision variables, say x1 and x2. It is one of the most popular approaches for solving simple linear programming problem. Okay, in the graphical method, uh, which is a easiest method, but it is used to for solving the linear programming problem which contains only two variables. So that is also major drawback also. Suppose if we have more than two variable, we can't apply the graphical method. That is, we can say that is a limitation of graphical method. Graphical solution is limited to linear programming models containing only two decision variables. Okay, now we are going to discuss about how to solve linear programming problem by using the graphical method. So here we can discuss the procedure. Step 1, convert each inequality as a equation. Here inequality means we can consider as a constraint. That constraint may be less than or equal to or greater than or equal to. So whatever may be, we want to convert into inequality into equality. Next, using that equation, okay, equality equation, then we can find the points. After finding the points, using that points we plot the graph. So using that graph we find out the feasible region. That is the third step. Then using that feasible region we want to find out the possible solution. Okay, set of all possible solution from the feasible region. So compute the coordinates of the corner points of the feasible region. These corner points will represent the feasible solution. Okay, so using that feasible region, we can find out the coordinates by using the corner points of the feasible region. So this is known as a feasible solution. What is feasible solution? It is satisfied all the constraints and non-negative restrictions. So then only we can say that is a feasible solution. And then step 5, substitute the coordinates of the corner points into the objective function to see which give the optimum value. So after finding the feasible solution, using that feasible solution, we apply that value in the objective function. Okay, from that we want to find out the optimal value. So that will be the optimal solution. So when we get the optimal value by using the some coordinates, so that coordinate is known as the optimal solution. So what is optimal solution? It optimizes the objective function. It satisfied our constraints. That is the maximize or minimize. That is our objective also. So now we discuss one problem. A company makes two kinds of leather belts. Belt A is a higher quality belt and belt B is of lower quality. So here a company have two kind of belts. Belt A is a high quality and belt B is a lower quality. The respective profits are rupees 4 and rupees 3 per belt. For belt A we get profit 4 and for belt B we get profit 3. So each belt of type A requires twice as much time as a belt of type B. So here, if you want to produce belt type A, which is need time twice as much time needed for producing belt B. And also, if all belts were of type B, the company could make thousands belts per day. So if you want to produce B only or A and B, but the company maximum produce for 1000 belts only per day. So what is the next one? The supply of leather is sufficient for only 800 belts per day for both A and B combined. So the overall supply of leather is also available for 800 belts only. Belt A requires a fancy buckles and only 400 buckles per day are available. For the fancy buckles needed for belt A, but we have only 400s per day. The same way 700 buckles are used for B per day. So we want to determine the optimal product mix. So in that problem they give a profit cost, they give a time requirements, and also they need the leather sufficiency, and also they given buckles requirements, how many buckles we have. So we can define by using this problem which one is our objective function, which one is our constraint, which one is our non-negative variable. So now we can use the linear programming problem. We can formulate this problem. So now we take it, let x1 be the number of belts of type A and x2 be the number of belts of type B. So now we can define a mathematical formulation for the given problem. So now we can define objective function. So in that problem they given a profit cost only. So we can consider as a maximize case function. That is our objective also, to find out the maximum profit. When how much quantity we need to get the maximum profit, that is our aim also. So we can define maximize z equal to 4x1 plus 3x2. That 4 is the profit get from type A and 3 profit get from type B. Okay, so that overall product for one unit is generated by 4x1 plus 3x2. So depends upon the x1 variable and x2 variable, then we will find out the overall profit value. So now we can define a constraints. First we can define a time constraint. So what is first constraint given in the problem based on the time? Suppose if we want to produce a belt of type A which is required twice time of for production of belt type B. Also we have a maximum availability to produce 100,000 belts only. So using that constraint we can define 2x1 plus x2 less than or equal to 1000, because we can't produce more than 1000 products. So that here we can use for less than or equal to symbol. For leather availability, for both product x1 and x2, but we have only the leather availability for producing 800 quantities only. So that x1 plus x2 less than or equal to 800. Here also we can't produce more than 800. So that here we can consider less than or equal to. So next fancy buckles depends on type A. We have only 400. So here also we can use for less than or equal to symbol, x1 less than or equal to 400. For buckles of type B belt, so we have only 700. Here also we can use less than or equal to symbol, x2 less than or equal to 700. So these are the 4 constraints we can find out from the given problem. So what is our non-restricted constraints? x1 comma x2 greater than or equal to 0, because our product is either production is nil, or if we have a production, that is a good one only. So that we can consider here greater than or equal to symbol. So now we can find the points by using the constraint values. So first take the first constraint. What is the first constraint is given? 2x1 plus x2 less than or equal to 1000. So we make it an inequality constraint into equality equation. Okay, so here we can consider 2x1 plus x2 is equal to 1000. So using this equation we find out the 2 points. So first we can put it x1 equal to 0, then automatically we can get x2 equal to 1000. So now we can put x2 equal to 0, then automatically x1 will be, that is equal to 1000 divided by 2, 500. Okay, so now we can find out 2 points. What are the points? 0, 1000 and 500, 0. So now we take it the second constraint. What is second constraint? x1 plus x2 less than or equal to 800. But now we can make it equality equation. So x1 plus x2 equal to 800. So using this equation we find out the 2 points. So first of all we put x1 equal to 0, then automatically x2 is equal to 800. Similarly we can put it x2 equal to 0, then automatically we get x1 equal to 800. So now we get another 2 points by using the second constraint. So what are the points? 0, 800 and 800, 0. So now we can consider for third constraint. What is the third constraint? x1 less than or equal to 400. If we convert into equality, then directly we get x1 is equal to 400. So similarly for the another one, fourth condition, x2 less than or equal to 700. So if we convert into equality, then we can directly get x2 is equal to 700. So using these points, we form a graph. Okay. So after forming the graph, we find out the feasible region. After forming the feasible region, we find out the feasible solution. Okay. So now we can draw the graph by using the points. Suppose if we consider the first constraint 2x1 plus x2 less than or equal to 100, we get 2 points. What are the 2 points? One is for 0,000, another one is 500 0. So here 0,000 will be considered as in x2 and 500 0 will be considered in x1. Then if we join these 2 points, we get a one line. Okay, that line is denoted as a red mark. Okay, so here we can consider all the area below the red line, because we can consider the constraints less than or equal to symbol only. So now we can consider the second constraint x1 plus x2 less than or equal to 800. So here we can get the 2 points 800, 0 and 0, 800. Okay, so first point is x1, second point is x2. If we join these 2 points, we get the another one line which is marked as blue color. Okay, so here also we can consider the area below this blue line only, because our constraint contains less than or equal to symbol. Then if you consider for the third constraint x1 less than or equal to 400, so we can directly draw a vertical line from the x1 axis at the point 400. Okay, we can consider all the value left hand side of the that block line, because we can consider in less than or equal to symbol in that constraint. Then we can consider the fourth constraint x2 less than or equal to 700. So we can draw a vertical line from x2 at the point 700. Okay, so here also we can consider below the area of that yellow line, because our constraint only for less than or equal to symbol. So now we can draw all the 4 lines. Okay, now we want to find out the feasible region. So that feasible region is shaded in that portion. After finding that feasible region, we find out the corner points. That is a feasible solution. That is we can known as A, B, C, D, E, F. Okay, these are the feasible solution of the given region. That is a feasible region. So here we can directly find out the points A, B, F, but we can't find directly for point C, D, E. Okay, so for finding C, D, E, we want to consider which 2 lines are intersecting in a particular point. Using the 2 equations, we can find out the x1 and x2 value. Okay, so what is A value here? 0, 0. B values 400, 0 and F value is 0, 700. Now we find out the point C. So what are the two lines are intersecting here? 2x1 plus x2 equal to 100. That is a red line. And another one is the black line. x1 equal to 400. Okay. So here x1 is 400. So you can apply x1 is equal to 400 in the 2x1 plus x2 equal to 1000. Then we can directly get the value 2 into 400 plus x2 equal to 1000. This implies x2 is equal to 1000 minus 800. That is x2 equal to 200. Okay, so now we get the point C as 400 comma 200. Now we can find out the point D. So in that point, red line and blue lines are intersecting. What is the red line? 2x1 plus x2 equal to 1000. What is blue line? x1 plus x2 equal to 800. Okay, we can use these two equation and solve and find the two values. So now we can consider the two equation and subtract from first equation to second equation. Automatically x2 value will be cancelled. What will be remaining? So 2x1 minus x1 we get x1. Okay, x2 will be cancelled. 1000 minus 800 equal to 200. So we get x1 equal to 200. So now we can apply x1 equal to 200 in the second equation. So we can choose any one of the equation. Here we can choose for second one, not for first one. If you want to, you can choose first one. So we can get it if you apply x1 equal to 200, then 200 plus x2 equal to 800. We can apply in the second equation. We get 200 plus x2 equal to 800. This implies x2 is equal to 800 minus 200, that is 600. So now we get the point D, 200 comma 600. So what is the point E? Here we get two lines are intersecting. What are the two lines? Blue line and yellow line. So we can find out the point E. So what is the first equation? x1 plus x2 equal to 800. Second one is x2 is equal to 700. So we are clearly x2 is equal to 700. So we apply x2 value in the first equation, x1 plus x2 equal to 800. Then we can directly get x1 value. So x1 plus 700 equal to 800. So we can get it x1 is equal to 800 minus 700, that is equal to 100. So x1 is equal to 100. So what is the point E? 100 comma 700. So now we find out all the points A, B, C, D, E, F. These are the feasible solution find out from feasible region. So using this feasible solution we find out the optimal solution. So that what is point A? 0 comma 0. So that is we can consider as x1 comma x2. What is point B? 400 comma 0. What is point C? 400 comma 200. What is point D? 200 comma 600. What is point E? 100 comma 700. What is point F? 0 comma 700. We apply that value in the z function. Z is equal to 4x1 plus 3x2. Okay. So if using the point A, we can get z is equal to 4 into 0 plus 3 into 0 equal to 0. We apply x1 and x2 value here. Then automatically z value equal to 0. For point B, x1 value is 400, x2 value equal to 0. So z is equal to 4 into 400 plus 3 into 0. We can get it 1600. Point C, x1 is 400, x2 is 200. What is z? 4 into 400 plus 3 into 200. Totally we can get 2200. Similarly, we can using that point D, we get z equal to 2600. Using the point E, we get z equal to 2500. Using the point F is equal to z value, we can get it 2100. So from this, what is our objective? To find out the maximum profit. So here, what is the maximum value of z? That is 2600. When we get this 2600 for applying that point D values, so 200 comma 600. So then only we can reach the maximum value. So maximum profit of the company is rupees 2600. At belt type of A is 200 and belt type of B is 600. Okay. Now we go for another one problem by using the minimize case. We already discussed one problem that is for maximize case. Now we can go for one problem for minimize case. So we have some ideas when we use the maximize or when we use for minimize. So at a university, Professor Simmons wishes to employ two people, John and Mary, to create papers for his classes. So in the university, Professor Simmons want to employ two person, named as John and Mary, to grade papers for his class. John is a graduate student and can create 20 papers per hour. And John earns rupees 15 per hour for grading paper. Okay, so John can create 20 papers per hour and John earns rupees 15 per hour for grading papers. So for like that, Mary is an postdoctoral associate and can grade 30 papers. So John is 20 papers and Mary is 30 papers per hour. They C grade. Mary earns rupees 25 per hours for grading papers. Okay, each must be employed at least 1 hour a week. So we want to assign at least 1 hour in every week. So that is another one constraint to justify their employment. If a Professor Simmons has at least 110 papers to be graded each week. So what is the aim of Simonson? He aimed at least 100 papers need to be corrected in a week. Okay, then how many hours per week should he employ each person to minimize the cost? So he want to assign a person. Okay, at the same time to minimize the grading cost. Okay, so here the problem is based on the to minimize the cost. Okay, so according to the nature of the problem, we can define is maximize or minimize. Here the problem is minimize case. So we can take it x be the number of hours per week John is employed and y be the number of hours per week Mary is employed. Now we forming the mathematical model. So first we can define objective function because our objective is minimize the cost. So minimize the function c is equal to 15x plus 25y because John earned rupees 15 per hour for grading paper and Mary earned rupees 25 per hour for grading papers. So that is x and y is the number of weeks. So overall function is 15x plus 25y. What are the constraints? So first constraint, each must work at least 1 hour each week. So that we can define the first two constraints as x greater than or equal to 1, y greater than or equal to 1 because they need to work at least 1 hour. And second one is must be create a paper per week. So and as a professor need at least 110 papers must be corrected in a week. So using the two persons, we can consider 20x plus 30y greater than or equal to 100 because every hour John corrected 20 papers and Mary corrected 30 papers. So depends upon the number of hours per week x and y. They want to find out the total number of papers they corrected. So here the professor need at least 110 papers. So that here we can use for greater than or equal to symbol. So that number of week is either 0 or greater than or equal to 0 only. So that here we can consider for x and y greater than or equal to 0. So now we form a mathematical model. So now we can apply graphical method to find out the solution. So first we want to consider the constraint. Okay, so inequality constraint, we can make it into equality equation. So what is the first constraint? X1 greater than or equal to 1. If we convert into equality equation, that is x is equal to 1. If we consider the second one, because we have only one point only, so that it is enough, x is equal to 1. If we consider the second one, y is equal, y greater than or equal to 1. If we make convert into equality, that is also y is equal to 1. Here y value only we have. The previous one, x greater than or equal to 1, so we get only x values. In the second constraint, we have only y value, so we can get it y value only. If we consider the third constraint, we can have a constraint as 20x plus 30y greater than or equal to 110. If we convert into equality equation, we have 20x plus 30y equal to 110. So using this equation, we find out 2 points. If we put x is equal to 0, then automatically 30y equal to 110. Then what is y value? 110 divided by 30, that is equal to 3.66. So now we can consider y equal to 0. This implies 20x is equal to 110. Okay, then x is equal to 110 divided by 20, that is equal to 5.5. So what are the 2 points? 0, 3.66 and 5.5, 0. So using all these points, we draw a lines in a given graph. Okay, what is the first equation? X is equal to 1. So we can draw a vertical line by using x-axis at the point x is equal to 1. Similarly, we can draw a horizontal line based on y-axis at the point x is equal to 1. And using that third equation, we can connect the 2 points, that is 0, 3.66 and 5.5, 0. If we join these 2 points, then we can get the one line. Okay, line. So we can consider all these lines, but all this line covering the common region is above this line only, because all the values, all the constraint contains greater than or equal to symbol only. So our common region will occur in the above region only, not for below. Okay, so here what are the common region? That shaded portion is known as the common region for all these 3 lines, because we can consider the above the line only, because all the symbols contains the greater than or equal to only. So if we want to consider the first equation, we can consider x is equal to 1 line, we can consider right hand side. Okay, if we consider the second equation, y is equal to 1, we can consider above the line. Okay, likewise, if we consider the third equation, 20x plus 30y equal to 110. Okay, that is also we can consider above the line only, 20x plus 30y equal to 110. So using all these 3 lines, we can collect the common region. So here we can find out the feasible solution as a and b only. Okay, because we want to find out minimum value, so we don't bother about the some higher value in that regions. So now we can find out the points. If you want to find out the point A, so which 2 lines are intersecting? That is 20x plus 30y equal to 110 and x1. The both lines are intersecting. Okay, so now we already know that x is equal to 1. So if we apply x is equal to 1 in 20x plus 30y equal to 110, then automatically we get y is equal to 110 minus 20 divided by 30. Okay, but then what is 110 minus 20? That is 90 divided by 30 equal to 3. So you can apply that x value in that equation, 20 plus 30y equal to 110. Okay, after simplifying, we get y value is equal to 3. So the point A is 1, 3. Similarly, we can find out the point B. Which 2 lines are intersecting in point B? That is 20x plus 30y equal to 110 and y is equal to 1. These 2 lines, y is equal to 1 and 20x plus 30y equal to 110. So now we clear that y is equal to 1. So if you apply y is equal to 1 in the second equation, okay, then we can get it 20x plus 30 equal to 110. Then 30 go to right hand side, 20x equal to 110 minus 30. Then x is equal to 110 minus 30 divided by 20. So automatically we get 80 divided by 20 equal to 4. So what is the point B? 4 comma 1. So which two lines are intersecting in a particular point? Using these two lines or the two lines equation, we can find out the 2 points. So same way we find out the point A is equal to A point is 1 comma 3 and B point is 4 comma 1. Okay. So now we can consider that feasible solution A and B, that is 1 comma 3, B value is 4 comma 1. So now we find out z values. So if you apply x is equal to 1 and y is equal to 3, if you want to consider point A, then what is z value? 19. If you want to consider point B, x is equal to 4, y is equal to 1, then what is z value? That is 15 into 4 plus 25 into 1, so 60 plus 25, 85. But here our aim is to find out the or to reduce the grading cost. So which one is the minimum value here? Z is equal to 85. When we get that z is equal to 85, if we choosing the point B, 4 comma 1. So we conclude that in order to minimizing grading cost, Professor Simmons should employ John 4 hours a week and Mary 1 hour a week at a cost of rupees 85 per week. Okay, if you assign 4 hours for John and 1 hour for Mary, then only the grading cost will be reduced per week. How much we get? 85. So likewise we can find out the our objective values. So here 85 is our objective value when we get that by using the point 4 comma 1. So now we can discuss some other kind of problem, unbounded solution. If the value of the objective function can be increased or decreased infinitely, such a solution are called unbounded solution. If we consider example z is equal to 3x plus 4 x1 plus 4 x2, what are the constraints? X1 plus x2 greater than or equal to 5, 3x1 plus x2 greater than or equal to 8. The non-restricted constraints x1 comma x2 greater than or equal to symbol. So after by using the constraint, we can find out the points. After finding the points plot in the graph, we will get the common region as a red line. But in that red line, we want to find out maximum value. Okay, so here that maximum region is unbounded. Okay, so that we can find out the feasible solution for the this kind of problem. Okay, minimize we can find out, but our objective is to find out maximum value because the upper bound of the region is unbounded, so that we can find out the solution. The feasible region is unbounded, hence z can be increased infinitely. So these problems is giving an unbounded solution because z value is increasing only, not for we doesn't get any particular values. So whenever we can consider, because it's go for the above only infinitely, so that we can't find out the we can't say the particular values is maximum, so that this kind of problem is unbounded. Okay, so when we consider for a maximum, this all the above value, okay, all the above value have a maximum region, then we can find out, but here it is not possible. If we consider above means it will go definitely for infinite. Next we are discussing for infeasible solution. It means the solution of the problem does not exist. This is possible when there is no common feasible region. If we consider the another one example, maximum z is equal to 2x1 plus 6 x2. What is the constraint? 4x1 plus 3x2 less than or equal to 12. And the second constraint 2x1 plus x2 greater than or equal to 8. And then non-restricted constraint x1 comma x2 greater than or equal to 0. So using that constraint we find out the points and plotted in the graph. After plotting the graph we want to find out the common feasible region, but here we can't find out the feasible region because the first line is less than, contains a less than or equal to symbol, so we can consider all the below the region of the line, first line. If we consider the second constraint, we want to consider all the values above the line, so that 2% does not intersect, so that we can't find out the common region for in that problem. So in this example we conclude that we can't find out the common feasible region. Okay, so the problem does not having an optimal solution. In this example common feasible region, common feasible region does not exist, and hence the problem is does not have a optimal solution. So this is the case of infeasible solution. So if it is infeasible means we can clearly understand that we can't find out the common regions. Okay, if we find out the common region only, we can find out some feasible points. Then only we can find out the optimum solution. Otherwise, we can't find out the optimal solutions. So thank you for listening my lecture. Once again, thanks a lot.